Hello everyone. Once again welcome to PM Networking. Guys, today in this video we are going to learn one very important protocol, that is ARP protocol. As you know, ARP stands for Address Resolution Protocol, and I know you already know that ARP is used to resolve MAC address from IP address. But guys, there are a lot of things in ARP protocol. After watching this video you will learn each and everything about this layer 2 protocol, right? So first of all, let me tell you that this protocol, our protocol, is a very important topic for network engineer interview. Many time interview asking question from this protocol. Interviewer can ask you to explain ARP protocol, what is ARP protocol, types of ARP protocol, right? How many types of ARP protocols are there, how ARP protocols works, and they can ask you like what is the use of ARP protocol. So multiple question interviews asking from this topic. So if you are a network engineer, you might have observed this question in interview, or if you are attending interview for network engineer, or if you are planning to attend, you are preparing for network engineer interview, guys, this video is only for you. After watching this video you will not have any doubt in ARP protocol. You will learn everything about this protocol. So make sure you will not escape this video and you will watch till the end. Okay, so this video will help you to get job in IT industry, right? To crack interview. At the same time, this video will help you to those people who want to attend CCNA exam as well, right? Because Cisco is also asking questions from ARP protocol in their exam, right? Okay, so this video is going to help to the people who is preparing for network engineering interview, who is people who is preparing for CCNA exam or CCNP exam, and we are going to cover CCNA to CCI level, right? Whatever things in ARP protocol, we are going to discuss everything in this video. Okay, so definitely this video will help you to get job in IT industry. You will be able to change job, right? And if you will learn something from this video, guys, after watching this video, if you feel that yes, I have learned something from this video, then you need to subscribe this channel. Okay, so let's begin without wasting our time more. So here, see, my topic is ARP, and as you know, ARP stands for Address Resolution Protocol. So see guys, first of all, the Address Resolution Protocol is a communication protocol that maps the internet protocol address to the media access control address. So actually ARP is used to map the IP address to MAC address. So actually whenever device don't know the MAC address of a device, and if they know what is the IP address of destination device, that time ARP protocol will used. So actually ARP is an communication protocol that maps the internet protocol address to the media access control. ARP work at layer 2, right? So that's why we called ARP is a layer 2 protocol. That means all the traffic of ARP protocol will generate at layer 2. That's why we called ARP is a layer 2 protocol. And some people are saying that ARP works on 2.5, right? So but guys, there is no 2.5 layer in OSI model, right? Either ARP can be a layer 3 protocol or it can be a layer 2 protocol. So ARP is a layer 2 protocol, so which is used to resolve MAC address from IP address. Fine. As you know, for basic communication, 4 things is required. First one, source MAC, then destination source IP, destination IP, source MAC, and destination MAC. These 4 things are required for basic communication. So suppose if I have two computer, both are connected directly, and computer 1 want to ping computer B. So computer 1 need these 4 information, and then only computer A can ping to computer B. So whenever a device need to find MAC address from an IP address, it will use ARP protocol. Let me explain through one scenario. Like suppose I have one PC here and I have one other PC over here, both are directly connected. Suppose MAC address of this machine is A, MAC address of this machine is B, IP address of this machine is 10.0.0.1, IP address of this machine is 10.0.0.2. So if you will ping 10.2 from PC A, so source IP will be 10.1, destination IP will be 10.2, source MAC will be A, and destination MAC is unknown. So this PC will look up their ARP table to find the MAC address of 10.0.0.2. So who will provide destination IP to the machine? You, network engineer, will provide IP address, destination IP address to the machine, but who will provide the destination MAC address to this machine? Guys, ARP protocol. For that only ARP protocol is responsible. Whenever a machine know destination IP, remote device IP address, but they don't know the destination MAC address, that time machine will use ARP protocol. And as you know, if my destination, if my remote network belongs to same network, then only this PC will generate ARP request for destination. Otherwise, if destination belongs to different network, so this device will generate ARP for their default gateway, right? That means what I am saying, suppose this is my computer which is connected to a router, and this router is connected to internet, and this internet is suppose connected through one HTTP server. Suppose this one is Google server, fine, and I want to ping Google server from this PC. So source will be my PC and destination will be Google server. Now source IP will be the IP address of PC, destination IP will be the IP address of Google server, right? But what will be the source MAC? Source MAC will be the MAC address of sender PC, and destination MAC will be the MAC address of their default gateway, right? So this machine need to resolve MAC address of their default gateway if destination belongs to different network. Okay, so always keep in mind that ARP is an address resolution protocol which is used to find MAC address from IP address. So suppose guys, here I have taken one example. Let me show you. Oh my god. Okay, so see, so whenever a device needs to find MAC address from an IP address, ARP will used. Okay, so suppose we have two computer here. You can see computer A, computer B. So suppose computer whose IP address is 10.1 and MAC address is A. Now I am talking about this computer whose IP address is 10.0.0.1, whose MAC address is A, needs to send ICMP request to the computer whose IP address is 10.0.0.2. So this time you can see destination belongs to same network because source is 10.0.0.1 and destination is 10.0.0.2, right? So this machine need what? Destination MAC address. But problem is computer A don't know the MAC address of 10.0.0.2. So to check MAC address from IP address, computer will look up their ARP table, right? So computer will look up their ARP table. You know how? Suppose this is my PC. Let me configure one IP here, 10.0.0.1. Okay, set 10.0.0. Just suppose 2 is my IP address, right? And now if you will check ARP table here, command that you need to run is ARP -A. So now you can see no ARP entry found. That means there is no any entry. So this machine don't know what is the MAC address of PC B, right? Same here. So this machine A don't know the MAC address of machine whose IP address is 10.0.0.2. So this machine A will generate what? ARP, right? So see, first of all, whenever you will run this command ping 10.0.0.2, source IP address will be 10.1, destination IP will be 10.2, source MAC will be A, and destination MAC is unknown, right? Because how machine will came to know that destination is unknown? See, destination will check their ARP table. In their ARP table, you can see it's saying no ARP entry found. So guys, now we are going to discuss working of ARP. So step 1 is computer 1 will generate a ARP request, right? Actual ICMP traffic is now hold. What I am trying to say, that I have two computer, A and B, right? IP address of this computer is A, IP address of this computer, sorry, MAC address of this computer is A, MAC address of this computer is B. Suppose IP address of this computer is 10.0.0.1 and 10.0.0.2 is IP address of this machine. Now if you will run ping 10.0.0.2 command from here, this machine at layer 3, this machine will generate what? ICMP traffic, ICMP actual mein request. It will generate an ICMP request. After that, it will hand over to IP protocol. IP protocol will add source IP, that will be 10.1. IP protocol will add destination IP, that is 10.2. After that, IP protocol will add TTL value here, right? They will add protocol field here. After that, it will hand over to data link layer. Data link layer will add what? Source MAC and destination MAC. So source MAC is A. To check destination MAC, this machine will look up their ARP table by running this command. And if there is no any entry found in ARP table, what ARPA protocol will do? Actually, at layer 2, which protocol is working? ARPA, right? So at layer 2, ARPA protocol is responsible to encapsulate frame. So what ARPA will do? ARPA need destination MAC address, but in the ARP table of this machine, you can see there is no entry found. So actually ARPA protocol will put this entire information on hold, and it will call to ARP protocol and tell to ARP protocol that I need MAC address of 10.0.0.2, please resolve it. So what ARP protocol will do? ARP protocol will generate a ARP request over here, right? There will be some information in ARP request. After that, it will hand over to again ARPA protocol. Now again ARPA protocol will add what? Source MAC is A, this time destination MAC. This time ARPA protocol is going to put destination broadcast, all F. That means all user in this network will receive this broadcast message, but there will be a target IP address, that is 10.0.0.2. Means I need MAC address of this IP address, okay, and it will forward to this machine. Actual information is on hold now. When this machine will generate reply, right, it will make entry in their ARP table. This PC will update their ARP table and it will put destination MAC here in actual ICMP request. Then they will add one type field 0x800, right, and then it will forward from the link. Okay, so there are two steps. First step is machine whenever device needs destination MAC address from IP address, it will call to ARP protocol. What ARP will do? ARP will generate a simple ARP request message. And let me show you guys what information will be there in ARP packet. So here you can see this is my ARP packet, right? So there will be target IP address, target MAC address. So target MAC address is 0.0.0, means target MAC address is unknown, right? This is not Ethernet header, this is ARP packet. So in ARP packet, source MAC will be the MAC address of PC1, you can see A, and destination MAC will be 0.0.0.0. Source IP will be 10.1 and target IP address will be the IP address of destination device, right, for which IP I am generating ARP. That will become target IP address. Okay, after that, once ARP protocol will generate ARP request, it will hand over to ARPA protocol. And what ARPA protocol will do? ARPA protocol will add this information, this header. This is layer 2 header, right? In layer 2 header, actually they will add source MAC is MAC address of PC1, destination MAC will be broadcast. Here you can see destination MAC is broadcast and type is 0x806, which is type code of ARP protocol. Fine. And this is your entire frame. Now PC1 is going to send this frame to PC number 2. This is step 1. And as you can see, target IP address in the request is 10.2. That means this ARP request is for the device whose IP address is 10.0.0.2. So suppose in my network, if there are 100 computers, right? So all 100 computers will receive the ARP request message. But which machine will generate reply? Machine whose IP address is 10.0.0.2. This machine will only generate reply. Okay, that means computer B will generate reply. So in step 2, computer, here you can see computer B will generate reply. Okay, and reply will be look like this. See the reply, guys, how reply will look like. See, this one is ARP reply. This time target MAC address is this one, right? This is the MAC address of PC1. It is sending ARP reply to PC1. Source IP is my IP address and source MAC is my MAC address, right? So this one you can see here, MAC address is B. So it's saying that source IP is 10.2 and source MAC is this one. That means this one is IP address of computer B and this one is MAC address of computer B. Now computer A is going to update their ARP table. So here now if you will run this command ARP minus A, you can see the entry. This is IP address 10.0.0.1 and this one is MAC address of computer B. How this device learn this address? Dynamically. So it will show you type of learning, that how I have learned this address. Okay, now guys, computer A has all information which is required for basic communication like source IP, destination IP, source MAC, destination MAC. Now computer A will encapsulate ICMP request packet into frame at layer 2 and it will forward to PC number 1. This is how ARP work. So essentially without ARP, a host would not be able to figure out the hardware address of another host. So this is the reason why we are using ARP. So many times interviews asking this question as well, that why we are using ARP. What will happen if there is no ARP protocol at layer 2? What will happen? Okay, so without ARP, a host would not be able to figure out the hardware address of another device. Okay, and whenever destination belongs to different network, machine will generate ARP for their default gateway only. So that things also keep in mind, because many times interviews asking this question as well, that suppose source belongs to different network and destination belongs to different network, and source wants to ping destination. What will be the MAC address of destination in the destination field? So in the destination field, MAC address will be the MAC address of default gateway. Now how to explain in interview? So see, I have written one line in easy language here, so you can practice this for interview. So when a source device wants to send an ICMP packet to another device, ARP perform two important tasks. First, the ARP program check the ARP cache table, that is ARP table, which consists of IPv4 address to MAC address mapping. Very good. The second task start if the ARP cache lookup does not provide a matching MAC address. So if machine will not found any MAC address in their ARP table, in this case the source server forms an ARP message, that is ARP request, which will be broadcast on the local area network LAN, right? After that, guys, types of ARP. Types of ARP is also very important, right? Many times interview asking how many types of ARP are there. So there are 4 types of address resolution protocol. Number 1 is Proxy ARP. Number 2 is Gracious ARP. Number 3 is Reverse ARP. And number 4 is Inverse ARP. So first of all, we are going to discuss Proxy ARP. So see what is Proxy ARP, guys. And Proxy ARP protocol handles request coming from IP addresses that are not on the local area network. So if a device is generating ARP request for the device which is not belongs to this network, belongs to same network. Okay, so when the request packet comes from a system outside the host network, the protocol configured router response to the ARP request packet. What it is saying, that see, first of all, by default Proxy ARP is enabled on all Cisco router interfaces, and Proxy ARP is used to provide MAC address of router interface instead of the MAC address of actual device. So first of all understand guys why we come up with proxy ARP. So see, suppose I have a router here. This router is connected to a server, and IP address of this server is suppose 10.1.2.1/24. okay, this machine is connected to a switch, and here we have one computer. IP address of this computer is suppose 10.1.1.1/24, and IP address of this machine, we have one more computer here, is 10.1.1.2/8. So suppose network engineer have configured wrong subnet mask on a PC, right? For this reason only we come up with proxy ARP, right? This is the actual reason why we come up with proxy ARP, right? So proxy ARP concept is helping network engineer to make communication possible between two devices even subnet mask is wrong. So here you can see, here subnet mask should be 24, but I have configured subnet mask 8. So now tell me, if this machine will ping Google server 10.1.2.1, what will be the source MAC and what will be the destination MAC? Suppose MAC address of this machine is A, MAC address of this machine is B, and MAC address of this interface is C, MAC address of server is D. So see, you will ping 10.1.2.1 from this PC. So source IP will be 10.1.1.1, destination IP will be 10.1.2.1. Because see, destination belongs to different network, because network ID of computer 1A is 10.1.1.0, and network ID of destination device is 10.1.2.0. that means destination belongs to different network. So source MAC will be A and destination MAC will be MAC address of default gateway, which is C. Fine, which is C. Okay, so it will ping. But when this machine will ping 10.1.2.1, right, guys, according to this machine, destination belongs to same network, because my network ID is, here you can see slash value is 8, that means my network ID is 10.0.0.0, and network ID of destination device is also 10.0.0.0 according to PC B. So according to PC B, destination belongs to same network, right? So when this machine will generate ICMP request, source will be 10.1.1.2, destination will be 10.1.2.1, source MAC will be the MAC address of PCB, and destination MAC will be, for now suppose destination MAC is unknown, so this machine will generate what? ARP request. ARP request for which device? For default gateway or for destination? So if destination belongs to same network, then directly this machine will generate ARP for destination device, because here we have configured wrong subnet mask. So that's why this machine will generate ARP directly for the destination device. And as you know, ARP is a broadcast message, and router never forward broadcast message. So when router will receive ARP packet on this interface, router should drop the packet. But because of proxy ARP, because we have already running this feature on each and every interfaces, so router will provide their own MAC address instead of the MAC address of 10.1.2.1. Actually, this proxy ARP feature tells us that whenever someone wants to resolve a MAC address of an IP address, and whenever you will receive the broadcast message, ARP request message, and if destination is reachable to you, please provide your own MAC address instead of the MAC address of server. So this router will generate ARP reply, and it will provide their own MAC address, right? So it will tell to this PC computer B that IP address of destination device is 10.1.1 and MAC address of destination device is C. So source MAC will be B and destination MAC will be C. So this is why we come up with proxy ARP. If you will disable proxy ARP here, then this machine will never able to communicate with server, right? Because then this machine cannot resolve, not resolve what? MAC address. Let me show you guys. So in packet tracer, let me take one router here. Okay, and suppose this router is connected to one server, and here we have two computer. Okay, and let me take one switches as well, switch as well here. So this is my switch. Okay, let me connect all devices together. Okay, now I am going to configure IP on the router. Say no interface config t, then interface f0/0, say no set, and IP address is suppose 10.0.0.10 dot not 0 1.1.10 255.255.255.0. Okay, this is IP address of f0/0 interface. That will be default gateway for end user. Now interface f0/1, say no set, and here suppose IP address is 100.0.0.1 255.0.0.0. Okay, let me configure IP on this server. So here IP address will be 100.0.0.2, subnet mask is this one, and default gateway will be 100.0.0.1. Okay, now I am going to configure IP address on PCs. So here let me configure 10.1.1.1. subnet mask will be 255.255.255.0, and default gateway will be 10.1.1.10. Okay, now here also on this PC I am going to configure IP. So suppose here IP address is 10.1.1.2 slash, sorry not slash, subnet mask is 255, and default gateway is 10.1.1.1. Okay, now I am going to disable proxy ARP from f0/0 interface. So interface f0/0. First of all, let me show you that proxy ARP is enabled here. How you can check? So IP interface fast ethernet 0/0. By running this command, you can see proxy ARP is enabled. So now I am going to disable proxy ARP interface f0/0. Say no IP proxy ARP. Okay, so now if you will verify, here you can see proxy ARP is still enabled. Proxy ARP is enabled. Config T interface f0/0 and say no IP proxy ARP. Okay, and let me check again. So it is enabled. Okay, so I think in packet tracer this command is not supporting, right? But if you will disable it, disable proxy ARP, then this machine cannot communicate. This machine cannot communicate. And now if you will ping server from this machine, see ping 10.1. Sorry, server IP address is, okay, so here's on server we need to configure IP from 10 network now. Okay, so 10.1.1.1. no, here on this server I will configure 10.1.2.1 2 dot, or suppose 2. Default gateway will be 10.1.2.1. okay, and on router interface as well I am going to change IP address. So config T interface f0/1, IP address is 10.1.2.1 255.255.255.0. fine. So let me ping the Google server from PC1, ping 10.1.2.1. see I am able to ping. Let me ping from PC3, ping 10.1.2.1. from here I am not able to ping because here you can see subnet mask is 8. Subnet mask is 8 and default gateway is 10.10. okay, so I think that's why this PC was not able to ping. Now it should be ping. So I think proxy ARP is disabled, right? It's showing us proxy ARP is enabled, but no proxy ARP is disabled on this interface. So that's why PC2 is not able to ping. And let me check again one more time. So it's saying that proxy ARP is enabled, right? But now proxy ARP is disabled, that's why this machine is not able to ping. Now let me enable proxy ARP on this router. Enable IP proxy ARP, and now if you will ping from this PC, see, so ARP, okay, sorry, ARP minus A. So now ARP table is empty. Now I am going to ping 10.1.2.google server. So see, now I am able to ping Google server, fine, because proxy ARP is enabled on router. And so, sorry, not so, ARP-A. So now you can see MAC address of 10.1.2. This is IP address of Google server is this one. So according to this PC, this is MAC address of Google server, but this is MAC address of router interface fast Ethernet 0/0. Router have provide their own MAC address instead of 10.1.2.1 MAC address, right? So you can check as well. So see, let me copy this MAC address from here. Let me paste it over here. So this is my, okay, and on this router, if you will check, so interface F0/0, see the MAC address of this interface is also same. Okay, so this is MAC address of router interface, and PC2 is saying that this is MAC address of 10.1.2.1, but this machine is saying that, so not so, ARP minus A. This machine is saying that this is same MAC address. This is MAC address of their default gateway, right? So this is the reason why we come up with proxy ARP, so that whenever network engineer will configure wrong subnet mask, PC should be able to access other networks, right? So if you will disable proxy ARP, it will not work, ping will not work. Okay, now let me move to next type of ARP. So this is proxy ARP. Now next ARP is, so however, instead of providing a MAC address of target host, router responds by pretending to be the destination and deliver its own MAC address instead of MAC address of destination device. Now next type of ARP is gracious ARP, right? Gracious ARP, guys, you know, whenever we configured IP address on any port, suppose this is my PC which is connected to another PC, whenever you will configure IP address here, right, maybe your IP address will be a static or dynamic, right, by DHCP. First thing that this machine will do is, this machine will check that my IP address is unique in network or not. So duplicacy, for that machine will use gracious ARP. This ARP also work at layer 2. Proxy ARP also work at layer 2. So suppose here I am going to configure IP 10.0.0.1. So it will generate, before assigning this IP address to their interface, this machine will generate gracious ARP, right, to check that is this IP address duplicate or not. For that it will generate a gracious ARP request. In ARP request, source will be same 10.1 and destination will be also same 10.1. So if destination is 10.1, so who will generate reply? The machine who is using this IP address 10.0.0.1, right? If there is no any machine using this IP address, that means this IP address is unique, so no one will generate reply. And within 2 seconds, if this machine will not receive reply from any machine, it will come to know that this is a unique IP address and it will assign this IP address to their interface. Okay, so gracious ARP is used to check duplicate IP address. So first of all, always keep in mind, whenever we configure IP address on interface of networking device, device will generate gracious ARP to check duplicate IP address. If IP address is not duplicate, then only your device will assign that IP address, and this is gracious ARP, guys. See how gracious ARP look like. So in gracious ARP also you can see target IP address is 10.0.0.1 and source is also 10.0.0.1, right? What I am saying, suppose I have one switch, okay, and there are some computer A, B and C. Suppose IP address of this computer is 10.1, IP address of this machine is 10.2, IP address of this machine is 10.3. So when this machine will generate gracious ARP, source will be 10.1, destination will be also 10.1, and suppose there is one more PC where I am going to configure one IP address, same IP address 10.0.0.1. So this machine will generate what? Our gracious ARP to check duplicate IP address, where source will be 10.1, destination will be also 10.1. Source MAC will be the MAC address of sender device who is sending this traffic, and destination MAC will be the 0.0.0, right? Unknown MAC address. So destination is unknown, okay, and it will forward from this interface. The switch will receive, switch will forward to this PC also, this PC also, this PC also. So these two PC will definitely drop this packet because target is 10.1, but here you can see 10.1 is already exist in the network. So this machine will generate reply, and when this machine will receive reply where source will be 10.1, destination will be 10.1, so this machine will come to know that this is not unique IP address, someone is already using this IP address, and it will not assign that IP address on their interface, okay. After that, this is gracious ARP packet, and through gracious ARP packet you can see Ethernet 2 header. So source will be unicast, source MAC address will be the MAC address of sender device, and destination will be broadcast, okay. So this is gracious ARP. So we have third type of ARP is reverse ARP. So as you know, a reverse ARP resolution protocol request IPv4 addresses from the ARP gateway router table, okay. New systems or machine that don't have the memory to store their own IP addresses tends to use this type of ARP. So this ARP will used by the machine who don't have the memory to store their IP address. So those type of machine will use reverse ARP to check their own IP address from their MAC address, okay. So the requesting device broadcast a reverse ARP packet, right, with its own MAC address in the address field of both sender and destination hardware. So both will be source MAC and destination MAC will be the MAC address of sender device. The reverse ARP server installed in the local network respond to the request, right. The server then locates a mapping table entry in the IP to MAC address. So it will maintain which table? Table from IP to MAC address. If the matching is successful, the server sends a respond packet with the IP address of the requesting computer. So this ARP is actually used to resolve IP address from their MAC address. And last type of ARP is inverse ARP. So inverse ARP does the opposite of what traditional ARP does. It map IP addresses using the associated hardware address, okay. So suppose I have two computer A, computer B. Suppose IP address of this machine is 10.1, IP address of this machine is 10.2, MAC address of this machine is A, and MAC address of this machine is B. So as you know, machines maintain which table? ARP table, right, for IP address and MAC address table. So it map IP addresses using the associate hardware address. So suppose this machine know the MAC address of destination device is B, but this machine don't know what is the IP address of device whose MAC address is B. So that time this machine will use reverse ARP. So these are four types of ARP, guys, very important types of ARP protocol. So that's all about address resolution protocol. So you can perform practical in packet tracer by yourself. So first of all, if you want to check gracious ARP, so let me remove IP address from on this PC and let me show you how this machine will generate gracious ARP. Okay, let me open simulation mode, and here I am going to assign IP 10.0.0.1 now. Okay, so you can see this packet, this is your gracious ARP. So first machine will check that this IP address is unique or not, right? And here you can see information. This is gracious ARP packet and this is Ethernet 2 header. Okay, so that's all for today, guys. We will meet soon in next video. Till then, stay safe. Bye bye. This is a small video which teach you our protocol. Okay, so bye bye. If you learn something from this video, please hit on like button.